Hello guys, today we will solve the problem related to mass and material balance. Before starting the problem, I will give short introduction how to solve this problem, this type of problem. You need first choose basis if it's not given. You see in this example, for example, it was given to us. That's why we don't need to choose any basis and draw a good block diagram. And third step is label the processing unit and all streams, fit all data into this diagram, write down all material balance equation in order to find unknown variables. And after finding all unknown variables, we need to put them to the table to see what's known, what's left, and etc. So before proceeding the solution of the problem, I recommend to you just stop the video here to solve the problem at least yourself, and then continue to watch if you solve correctly or not. But we can start. The feed to a continuous distillation column comprises 50 mole percent butane, 30 mole percent pentane, and 20 mole percent hexane. We need to draw the block diagram. I drew it previously in order to save our time. We see we have feed and we have composition for each three component, and that's said. And the distillate to product, I denoted it as D, which accounts for 55 mole percent of the feed. And like we have feed, we have distillate. This distillate is just equal to 55% of feed, and also this contains also C4, C5, C6, each of these components. But as we know, in distillate we should have like lighter components, so that's why 90% of it is C4, and we know that all summation of all percentage should be 100 in one product. So you see here. We denote C5 as X, and C6 should be 100 minus 90 minus X, and it's equal to 10 minus X. Coming to bottom, again, it's stated from the bottom product contains 42 mole percent of hexane. So again, we have bottom product, 42% of it is hexane. We denote C for Y, and C5 will be 100 minus 42 and minus Y, and it's equal to 58 minus Y%. Okay, we draw our block diagram and put all stream and composition of them here, and then we need to solve the problem. So here you see that basis is 100 kilomole of feed. So it means that we have basis. You can choose basis whatever you want. You can put 100 mole, 1000 kilomole. It totally depends on you. As it's said here, we need to find mole composition. That's why it doesn't matter for us. We put feed as 100 kilomole and start to solve the problem. So step 1 is to write general mass equation. General mass equation is feed is equal to distillate plus bottom product, as you see from the diagram also. So we know that our feed is 100, our distillate is 55% of feed, which is again the same number, 55, and plus B, which is bottom. So we found here that bottom is equal to 45, and step 2 is to calculate the butane percentage. So we write the equation for butane. 100 multiply like you can write it as 100 multiply 150 divided by 100, or you can put it as like 100 multiply as fraction 0.5 is equal to 55 multiply 0.9 as fraction, or like this you can put, and plus again in the bottom it's Y is composition, like percentage is Y. That's why we need to write bottom, which is 45 multiply Y, the fraction the percentage of C4, and divided by 100. So here again we solved the equation and found that Y is equal to 1.11111 percentage. I just rounded it and wrote like this. And step 3 is the same with step 2, but we need to write it for another unknown. We can write it for C5 also, but I chose to write for C6, as in C5 we have two unknown, although we found one of them, which is Y, but again calculation will be a little bit longer. That's why I chose step 3 with hexane. So hexane in the feed, hexane is 100 multiply 0.2. In the distillate, hexane is 55 multiply 10 minus X divided by 100, and in the bottom it's 45 multiply 42% and divided by 100. So again I just simplified the equation in order to solve X and found that X is 8%. So step 4 is complete the table. I already found Y, which is the composition of C4. I found X, which is a percentage for C5 in the distillate, so I can easily follow the next step and complete the table. You see, I put all the table here and wrote all non-variables that was given in the problem statement. So I will take my pen and wrote another variables. You see, in the distillate, it was given that C4 is 90%, and we found X as 8%, which is 0.08 as a fraction. Sorry for my handwriting. And if it's 8 percentage, C6 will be 10 minus 8, which is equal to 2% or 0.02. So you see, all summation of all these fractions should equal to 1, as you see. And coming to converting them to kmol, you should just multiply the fractions to the amount of distillate and write down all the variables. Like 0.9 multiply 55 will give us 49.5, and all variables here I will put them down. Like it will give us 4.4, and this will give us 1.1. Okay, and summation of them again will be 55 as it's assumed. Coming to bottom product, we know only the C6 from the statement of problem, but we found that y is equal to 1.1, and if we convert it to fraction, I just will round it and wrote like this, 0.01. And for pentane, I will just put this number here, and we'll find for pentane it will like 0.57, and the summation of them, as you see, again will be 1. Coming to kmol, again you need to multiply like the amount of bottom to this fraction, and I will write them down. 0.5, 25 multiply 25.6, and 18.9, and the summation of them should equal to 45. You see, again, mass balance is correct. 55 plus 45 will give us 100. So this is all from the solution of the problem. You can continue to follow us to see additional problems related to mass and material balance.